In this tutorial, I'm going to talk about Flynn's classification. Well, this is a computer organization tutorial series, and since it's the first lesson, it's going to be a bit short. So let's start. Um, I'm starting with Flynn's classification. It's very basic and it's pretty easy, and its main purpose is multiprocessing, to support multiprocessing. Okay. So what are the different classifications? The different classification that Flynn made is SISD, MISD, SIMD, and MIMD. What is SISD? SISD is single instruction, single data, single instruction stream, single data stream. What this means is there's going to be one instruction and one data processor. Well, who sends an instruction? CU sends an instruction. Okay, I've mentioned this as actually a control unit. CU control unit sends the instruction. Who processes the data? The processing unit or processing element processes the data. Okay, so single instruction, single data means there is one control unit and one processing unit. A single instruction is sent to the processor and the processor processes the data. So this is single instruction, single data. Similarly, MISD. MISD means multiple instructions, single data. Means there would be multiple instructions but only one data processor. This means multiple instruction. Okay, control unit can send only one instruction at a time. So multiple instructions means there are more than one control unit. So there is more than one control unit, multiple. Okay, and single data. Single data means there is only one processing unit. Single. Okay, a processor can also process only one operation at a time. So a processor can only process one data at a time. So single data means single processor. Similarly, multiple data means multiple processor. So next comes SIMD, single instruction multiple data. It means there is only one instruction. Okay, when I'm saying there is only one instruction or multiple instruction, it means per clock cycle. SIMD, single instruction multiple data. It means there is only one instruction given but there are multiple processing units. So single instruction means one CU and multiple data means more than one processing units. Okay, SIMD means single control unit and more than one processing unit, single instruction and more than one processor, as simple as that. Then comes MIMD. MIMD means multiple instruction multiple data. This means there are more than one instruction, means more than one CU, multiple CU, and also multiple data means multiple processors. So it means multiple data and multiple instructions, means multiple CU, multiple processing unit. Okay, what's an example of all this classifications? Example is array processor. Later in a later video series, in a later video, I'm going to discuss this array processor concept. For the time being, just keep in mind as an example. What is the example of all this? Array processor is the answer. Okay. Now let's look into a few terms here. PE. PE means processing element or processing unit. Then CU. CU would mean control unit. CU. And M would mean memory unit. M means memory unit. Okay, this is all for this page. Now I'm going to start the next page. Okay, now let's look into the structure of a SISD system. Single instruction, single data. Single instruction means there is only one control unit. Control unit sends the instruction. So single instruction means only one control unit. And single data. Data means processing unit. Single data means there is only one processing unit. So the diagram would be something like this. There is one control unit and one processing unit. This is the memory. Suppose how the function takes place. Data or instruction from the memory goes to the control unit. Control unit then sends the instruction to the processing element. Then it returns the result to the memory. So the arrow goes like this here. And as you can see here, arrow is on this side as well. What this means is the processing element, it gets the data from the memory. So data from the memory comes to the processing unit as well, because processing unit, what does it does? It processes the data. So data should come from the memory because data lies in the memory. So processing unit gets the data from the memory. That's why there's a both-sided arrow here. Now what does processing unit do? Actually, for you to understand better, suppose you give instruction A plus B. A and B are stored in the memory. CU sends a signal for addition. What processing unit does is actually computes A plus B. Now CU won't provide the A's value and B's value. From where will processing unit get the value? It will get the value from the memory. It will get the value of A, get the value of B, and the instruction would be coming from CU as addition. So A plus B. And where does the result go? A plus B. It goes back to the memory. So there is a two-way arrow here. Example: uniprocessor, pipeline processor. Just know these terms. You need to understand them in this video. Otherwise, I will be deviating. Those are separate topics altogether. Next architecture is SIMD, single instruction multiple data. Single instruction multiple data. What does this mean is there is only one CU. The one CU is here, and multiple data means there is multiple processing unit. So these are the processing units. It starts from 1, 2, then goes on 3, 4, 5, 6 up to n. There are n processing units, suppose. And this is our memory. Well, in the memory there are data sets. Okay, data sets. In the memory there are data sets where the data is stored. Suppose the data sets are like this: 1, then 2, then 3 up to n. Then how the operation happens here is actually the data and the instruction, they are given from the memory. The control unit actually interprets it. To explain you a bit better, it interprets what it does. The memory just stores them. Okay, so this goes from the memory, your CU, and CU, after processing all of them, sends the respective instructions to the processing elements. It sends instruction like this to first processing element, then second, then third, like this. Okay, so it goes from memory to CU and CU to PE, and the PE processing element gets and sends data to a particular data set. So for PE, data is DS1. This is called localized data set. For PE2 is DS2, again localized. All the data here is localized data. The rest is very simple. It goes from memory to CU, CU to P, and from P to dataset or memory, and to and fro. This is like the previous tutorials, just like the previous examples. Next, let's go into the third page. MISD. MISD means multiple instruction but only one processor. Well, this is not practically used. Sorry for this. It's not practically used. There are a lot of reasons for it. Um, like multiple instructions are coming, then how to process them. And only one processor to process them. As scientists are thinking about it, it's not implemented actually. Well, next is MIMD. MIMD means multiple instruction, multiple data. This is diagram. There are multiple instruction, multiple data. One CU, one instruction. Multiple instruction means multiple CU. Multiple CU and multiple data means more than one CU, more than one processing element. So for data set 1, there is one CU, one processing element. Data set 2, one CU, one PE. Up and then goes on to data set N. And for data set N, there is one CU, one PE. So the data goes from dataset 1 to CU1, from CU1 sends instruction to PE1, and PE1 gets the data from the dataset 1 and calculates and returns the data back to dataset 1. Because processing unit and control unit, they cannot store data, they don't have any memory, so it has to return the value to the memory. Then the same thing, DS2, CU2, PE2, and DSN, CUN, PEN. Data goes flows in this way from the particular data set to the CU, then to the PE. So this whole thing is one block you can think of. Data sets CU, then PE. Okay, let's not discuss all this. So this is it guys for this video. I have discussed just the basic classifications, the 4 types: SIA, SD, SIMD, MISD, MIMD. The next video I shall discuss something else. Well, before I leave for this video, I'm going to show you something. All of these images, all these are going to be available in my GitHub um, site, and it's going to be in the description below. If you want them, you can just download them and view them. Thank you, and if you like this video, do it like and do share it with your friends. Thank you.